So we look at this example on page 175. We want to find the greatest common divisor of these two numbers, 12,378 and 3,054. We know there are many ways to find the greatest common divisor. We can break down each number and we can take multiples of the big number and try to find a number such that take the break down each number and we factor each number, can try to find out the common factors. But because these two numbers are both very big, it's very difficult. It takes a lot of time to factor each number. So we're trying to use Euclidean algorithm to solve this question. And the second part is when we get the greatest common divisor, can we write it as the first number times an integer? We need to find out what this x is, plus the second number times another integer, y, and we want to find out what y is. So this is how Euclidean algorithm is to find out the greatest common divisor. We take the big number, 12,378, divide by the smaller one, 3,054. We found the quotient is 4, and the remainder is 162. So we can write 12,378 as the quotient 4 times the divisor plus the remainder. So that means 12,378 contains this many 3,054, 4 times 3,054. But we still have some remainders. We have something left, 162. And similarly, the next step, we keep doing this. We're going to take the smaller number of these two and take the remainder and divide them. So big one divided by small one. Long division, again, we get a quotient is 18, remainder is 138. So 3,054 can be written as 18, the quotient, times 162 plus the remainder 138. And now we're going to take 162 and the last remainder 138 and divide them again. So 162 divided by 138, quotient 1, remainder 24. So we write 162 as 1 times 138 plus 24. And again, 138, take 138 and the remainder 24 and divide them. So how far should we go until we get the remainder 0? So the remainder is still 24, and so we should divide again. 138 divided by 24, 5, quotient, remainder 18. 138 is 5 times 24 plus 18. And continue, because the remainder is still not 0. So we do 24 and take the remainder 18. 24 divided by 18. So the remainder is 6. And 24 is 1 times 18 plus 6. Remainder is still not 0, so we take 18 again, divide by 6, so the 3, and the remainder is 0. So now we can stop. And what is the greatest common divisor? The last remainder before 0, so that would be 6. So that means the greatest common divisor of these two numbers is 6. And the second part, we want to write 6 as, so 6 has something to do with these two numbers. We want to write 6 as the first number times an integer plus second number times an integer. So how to find x and y, these two integers? We start from the beginning. We have all these expressions here. In fact, if we try to find out the greatest common divisor, we don't need these expressions. We just need to do long division until we get 0, and the very last remainder before 0 is the answer. But if we want to try to find those two integers, we have to use these expressions here we have. And we're gonna rewrite each expression. Find out what the remainder is. So 162, we subtract 4 times 3054 from both sides. So we'll describe 164. The remainder is always the dividend minus the quotient times the divisor. So get 162. So it's kind of like if we have this much money and we spend this much, we have $162 left. So if we can, for example, if we have this much money and try to buy, let's say, a big TV, so each one costs $3,054, and that means we can only buy 4 of them, and we have $164 left if we're not considering tax. So that's the remainder. And similarly here, 138 equals 3,054 minus 18 times 162. And 24, the remainder equals 162 minus 138. This quotient 1 can be omitted. And 18 equals 138 minus 5 times 24. And 6 equals 24 minus 1 times 18. 1 can be omitted, so it's just 24 minus 18. And 6 is the greatest common divisor. So we start with the very last, the last expression, 6. So 6 is equal to 24 minus 18. But what we want is these two numbers given originally, not 24 and 18. So we try to plug back until we reach the original two numbers. So I'm going to first look at the previous expression I have. It's 18. So in this expression, I can get rid of 18, replace 18 with 138 minus 5 times 24. And just keep in mind, we don't want to multiply out 5 and 24. We don't want to multiply out. Think of 5 as a coefficient of 24. So we keep the coefficient and we try to get rid of parentheses. So negative 1 times 138 is negative 138. Negative times negative 5, it's positive 5, and times 24. So first step, get rid of parentheses, and now we can combine like terms, like we are combining the letters. For example, 1x plus 5x is 6x. So if we think of 24 as x, so we get 1x plus 5x is 6x. So because we have 124 here, 5 24s here, together we get 6 24s. And we don't want to multiply them out. We want to keep this 24 because we want to our goal is to go back to the original numbers. So we keep substituting. So minus 138. Now the next step, if we look at the next expression, is 24. So I can replace this 24 with 162 minus 138. Plug in here again. And now we multiply out 6 times, it's like distributive property. 6 times 164 minus 6 times 138 minus 138. Notice the last two both have 138. So we can combine them together. So minus 6 of them minus another one. So together we subtract 7 times 138. And now if we go back to look at the previous expression, it's 138. So that means I can replace 138 with this expression, 3,054 minus 18 times 162. So that's how we get this. And multiply out again, distribute. So 7 times 3, the 3,054. Negative 7 times negative 18 is 126 and times 162. Let's think of this as 7 and negative 7 times negative 18x. So we have to keep them, not to multiply out. Okay, now if we look at the expression here, notice we have 162 here, 162 here. 6 of them plus 126 of them together, we get a 132 of 162 minus 7 times 3054. So if we compare this expression to what we want to have, we want to have these two numbers, original numbers, in there. We already got one of them, so if we replace one more time, we should have the number we want. So 162, look at the first expression we have, 162. I replace 162 with this expression, 12,378 plus minus 4 times 3054. And then multiply out again distributive property. So 132 times 12378 minus 132 times 4, that is 528 times 3054, and minus 7 times 3054. So these very last two can be combined again. Minus 528 of this number and minus another 7 of them. So together we're subtracting 535 of this number, 3054. So we can rewrite it as, because it's minus 535, it's the same as plus negative 535 times 3054. So that's what we want. So if the answer will be, the greatest common divisor 6 can be written as 12,378 times, oh, I'm sorry, it should be 132 here, plus 3054 times negative 535. So the idea is just keep, when we have all these expressions, just keep plugging back. So the previous expression, so replace this 8 by the expression, and then replace 24 by this expression, and then we will get rid of 24 and 18, and then we will have 138 in there, and then we replace 138, and then we will have 162 in there, and then we replace 162. Finally, we will get to the original two numbers, 12,378 and 3054. So that's the homework assignment gives us an idea what Euclidean algorithm is.